Storage Explorer is a tool for managing Azure storage. You can download it via the URL on screen in case you don't have it yet. I previously installed it, so let me launch it. Once you've installed and launched it, you should see a screen that looks like this. If you're not signed in yet, choose Sign in with Azure and sign in with your Azure account. Once that's done, you can click the hierarchy button here, in case it hasn't been opened automatically yet. What you find here is an emulator, which is a built-in local emulator to work with in case you need one, but we are more interested in our real Azure storage. My Visual Studio subscription has automatically been added here as well, since I signed in. And here I should be able to find my storage account. If I'm not mistaken, we named it appdevstdevwe travel. And from this, we can find our table storage destinations table. So here we go. From this user interface, you can now manipulate the table storage tables. You can add new tables, you can edit the data within them, you can import or export them, and so on. It's of course personal preference, but I think this is a bit more convenient than simply doing everything directly on the portal. If you're used to working with something like SQL Server Management Studio or likewise apps, I'm sure you'll feel right at home. Blob storage is coming up next. We're going to need images as blobs for that. So let me manage that as an example from Storage Explorer. So let's go to blob containers here. If we open that, you see that one was already automatically created. That's for storing logs. We will learn more about that in an upcoming section. What we want to do is create a new blob container, one for our images. So let's click Create Blob Container. Such a container can only contain lowercase letters, numbers, or hyphens. So let's name ours Destination Images. And to it we now want to add images. Let me click Upload here and choose to upload file. In my Dome Train demo folder, I added a few images to work with. Let's first choose an image of Antwerp. Now let's open this. And there's a few things we need to configure here. The first thing we need to fill out is the blob type. Blobs come in three types. A blob is optimized for streaming and storing large amounts of unstructured data. So think about images, videos, backups, logs, and other files. Page blobs then are used for random read-write operations. They're typically for virtual machine disks. You can actually gather that from the UI, where upload VHD or VHDX files as page blobs is a recommended thing that's automatically checked. VHD or VHDX files, those are virtual machine disks. Lastly, append blob is optimized for append-only scenarios, such as logging again or writing data sequentially. We are dealing with images, so block blob is the thing we want to select. The target access tier then has to do with cost, data access, and data retention. The hot tier here is optimized for frequently accessed or modified data. It has a higher storage cost, but lower access cost. The cool tier here is ideal for infrequently accessed data. It has lower storage costs, but higher access costs compared to the hot tier. The cold tier then is for rarely accessed data that still requires fast retrieval. It has even lower storage costs and even higher access costs than the cool tier. Lastly, the archive tier is an offline tier for data that's rarely accessed and has flexible latency requirements up to a few hours even. It's stored for a minimum of 180 days. Let's assume that our API is a popular one. I'm going to go for the hot tier here. That, by the way, is also the default tier. The destination directory then can be seen as a potential subdirectory in this blob container. So you can create hierarchies inside of one container. For the demo, we don't need that. What you also see is that I can add tags here. That's important. Through these tags, which are index tags, blobs can easily be categorized and found. So I'm going to give all our images a destination identifier tag, which will serve as the link between an image and a destination in our table storage. You can of course add multiple tags in case you want to reuse blobs for different types of categorization, by name or by what's in a picture, for example. So let me give this a destination identifier of 1, which is the identifier of Antwerp in our blob storage. And let's upload the Antwerp image. Let's upload a few other images. I'm going to start with a second one for Antwerp. All the rest will remain the same. The destination identifier for this one is 1 as well. There's our second image. And then let's do the same with an image for San Francisco. The destination identifier for that is 2. And another one for Sydney, which has 3 as destination identifier. Alright, that should do it. Now let's see what the effect of this is over on the Azure portal. Let's go to Containers here. And here we find our destination images container. And in it we find our blobs. Before we continue, there's one thing I want to change. If you look at the blob container here, you see that anonymous access level is set to private. That's no good. We're storing images in here that we want to be available publicly. So we want to make access public as well. So let's go to the configuration blade and choose to allow anonymous access for blobs. Let's click Save. This, by the way, does not mean that all your blobs are now anonymously accessible. It simply means that you can now decide at level of each container whether or not you want to allow public access. And with that, anonymous blob access is potentially enabled. Let's go to our container. Let's select it and let's change the access level to anonymous read access for blobs. And there we go. That's all we need to do. Now let's integrate with this from our code. For the demo, let's start with returning the image blob as a URI to the actual image, together with the rest of the destination details. The first thing we need for that is a library to integrate with blob storage. That package is named azure.storage.blobs. Let's install it. And there we go. What follows is kind of like what we did with table storage. The package I just added contains a blob service client, which we need to connect to our storage account. So let's open service collection extensions here. Here I added a new table service client in a previous demo. What I want to do now is add a new blob service client. Let's import the azure.storage.blobs namespace for that. And this too needs a connection string to our storage account. Right from this moment on, I can inject a blob service client. I want to inject that in our search destinations handler. Also, just like we did with the table service client. So let's do that. Blob service client defined in azure.storage.blobs. So let's import that namespace. And let me name it Travel Inspiration blob service client. Now let's store it in a field. I prefer my private field to start with an underscore. There we go. On this blob service client, likewise methods as on the table service client exist, but this time in the context of working with blobs and blob containers. So we can create a blob container here, delete a blob container, look for one, and so on. Now, the scenario we want to enable here is that we want to load the image URIs, so the URIs to an image in blob storage for the destinations that are going to be returned. So, the first thing I can do here is state that if there are no page destination DTOs, we can simply return and we don't need to call into blob storage at all. There we go. Otherwise, we first want to get a hold of our container. Just like we got a hold of our table through the Travel Inspiration table service client, we can get a hold of our container via our Travel Inspiration blob service client. For that I call into getBlobContainerClient, and I pass through the name of our blob container, which was destination images. On this container, we can then find a bunch of methods to interact with the actual blobs. One of them is named find blobs by tags. That sounds interesting, because what we want to do is find all the blobs with a destination identifier tag that matches the destination ID, the identifier at least, of the destination DTO. That's why we added that tag. So the first thing we need to construct is the search expression, the where clause. And just like with table storage, what we can do here is quite limited. As you can see, AND is possible, but OR is not. And that makes sense for this type of data storage. So that means that we have to fetch each blob one by one to get the URI. We can't just fetch a series of blobs in one go. So what that means is that we need to fetch each blob one by one and then get the URI from it. Let me first, at level of the destination DTO, add a property to hold the images. One destination DTO can have multiple images. As you know, we added 2 different images for Antwerp. Then let's run through all the destinations on the page. So we can do that with a for each loop. So for each destination in page destination DTOs, I'm going to get the related blobs. We do that by calling into the destination images container clients find blobs by tags method. And what we want to pass through as where clause here, as query, again this is OData, is that we want the destination identifier, which is one of the tags, to equal the ID of the destination, which is the identifier of the destination. As a best practice, we also pass through the cancellation token, and that should give us all the blobs. And what do we want to do next? Well, for each of these, we need the image URI to one specific image blob. So we run through all these blobs, and for each blob, we create a blob client. Through a blob client, you can get information about one specific blob or manipulate and do things with that one specific blob. We can get one of those blob clients via the destination images container clients get blob client method. We pass through the blob name to identify the blob we want the blob client for. And once we have that blob client, we can do things with the actual blob. We can copy, we can create a snapshot, we can delete it, but we can also get the URI from it. We could generate a URI with a shared access signature, but we made the blobs themselves public, so we don't need that. We simply need the regular URI. To our destinations image URIs collection, we add the absolute URI to the specific image blob. We find that via blobclient.uri.absolute URI. Alright, that should do it. Let's save this and let's give this a try. I've got a request here from a previous clip in which I searched for all destinations matching Antwerp, Belgium. Let's send that request again. And we seem to hit an error. Error parsing query near character unexpected. Alright, I think I made a small typo. Let me just fix that. Let's see here. This is the where clause. And indeed, I forgot to close the quote. Things like that happen. Let's give that another try. That's one of those things I hope AI will solve in the future. My typos. Alright, let's send this request again. And there we go, much better. We now get back the ID, name, and the image URIs. So these are direct links to the images in our blob storage. Let me open one. And there we go, a very famous statue on Antwerp's city square. So that's how we can interact with blob storage and read blobs from it. Up next, writing blobs.